Okay, so I have a graph where I've plotted the data that is given in the video about the 3 different metal samples. So you want to make a line graph because when we're talking about bar graphs, we're usually talking about like categories, and it's not a very common graph that we're going to actually make very many of. So we're usually going to be looking at line graphs. So I went through and in the video, it gives you the different sample data. So I drew my graph, just kind of how it gives you the little template in the lab. So I plotted my different points, and I went ahead and just made each sample a different color. That's fine if you want to do that. If you don't want to do that, that's fine too. But what we're really kind of looking at is, even if you didn't make these different colors, we're kind of noticing that we kind of have different groups. Like, I have these 3 dots here, and then we have these 3 dots here, and then we have these other red ones that are kind of lower down beneath. So we're seeing that there's the 3 different samples, their data points kind of group together. So what that tells me is that their relationship between mass and volume is not the same. And like I can kind of see if, when the volume is 1, the red sample has a very small mass, around 2.5 grams, but the blue sample 3, had a very large mass, around 7.5 grams. So I can see that they're not the same substance because their amount of mass per volume, I'll just kind of write that up here, the amount of mass per unit of volume is not the same. I can see that they're different. And if you think about the formula, when we think about mass over volume, what we're really talking about is density. So the density of these 3 substances are different. So the next thing the directions ask you to do is draw a line of best fit. A line of best fit is kind of like, it's not connect the dots. We're not trying to connect every dot together, where you get those real zigzag lines. What we're doing is we're drawing essentially like an average line. So I know that I'm always going to start at 0 because I know that when there's no mass, there's also no volume. So 0, 0 is going to be my origin point. And then my goal is to just kind of draw like what we call a line of best fit, a straight line that's going to kind of go through the middle of the point. So it doesn't necessarily have to intersect every point. Like I'll draw an example, and this is kind of the best I can do. Free-handed, which is fine. If you have a ruler, you can use that. But notice how, if I intersect the bottom point, there's no way for me to intersect the top point. It just isn't going to work without, playing connect the dots and making my line crooked. I don't want a crooked line. I want a very straight line. So that's my line of best fit for my green samples, my sample 2. I guess I could have gone in order. I'll do my sample 1. Okay, that's my red sample. So again, I'm going to start here at the origin, and I'm just going to try to make as straight of a line as possible that's going through my sample. And, I don't know, that looks a little low. I probably could, that looks a little bit better. So you can see I'm not necessarily intersecting. You may be able to do a better job if you have a ruler, but that's decent freehand. And then lastly, we have our sample 3, which is our blue dot. So this one, it may overlap some of your lines, which is okay because we're not worried about these other sets. I'm really just trying to draw a line of best fit through my blue, and I'm going to try to do this. There we go. So I've drawn 3 lines of best fit, and I can kind of overlap my green a little bit, but it's okay. Maybe they're similar samples or some similar substances, so it's okay. Now what you're going to do is you're going to draw, you're going to calculate the slope of your best fit lines. So let's just kind of go one by one. So I'm actually going to take off this blue line real quick. That way we can calculate the slope of my green line so we can see it. Your line may be a little bit different, okay, so that's okay. Let's start with sample 1, the red one, all right? So when we calculate slope, right, we know that slope is just my rise over run. So the easiest thing to do is to find kind of a good intersection point, and I'm going to choose like a different color here so we can kind of see what I'm doing. Like I'm going to choose this spot right here because it intersects nice and neatly with some of my like my values, those two little lines. And then I'm going to choose another point. Let's see, I'm going to choose this point right here. That's a good little intersection there. So I'm just going to count my rise over run. So I'm going up to here. So I'm going from 0.05 up to 3. So my rise is 2.5. I'm sorry, that's not 0.05. That should be 1.5. I can't, I'm not thinking straight. Let me just fix that right there. Oh, goodness. All right, so this is 1.5. So 1.5 to 3 is 1.5. So that's my rise. And then my run, I'm going from 0.6 over to 1.15. So if I was to subtract, right, because I want the difference, that's like 1.09. So that means that my my run is 1.09. So to find my slope, I'm just going to plug in my rise was 1.5, my run was 1.09, and I do not have a calculator with me. Let's see, I'll just do it right on here. So I have a calculator somewhere, maybe. I don't use this very often. Maybe I didn't put a calculator in here. Okay. Sorry, we're just gonna skip that. So you can type that in. And solve. So this would be my slope, 1.5 divided by 1.9. So I want like a whole number, you know, something close to a whole number. You're going to do the same thing for each line. So, you know, my green line, you know, I might choose like this point and this point. So I'm going up from 1 to 3. So that's rise is 2. And my run is, let's see, 0.15 over to 0.45, so 0.3. So that means my slope here is going to be 2 over 0.3. Okay, so we'll get a whole number, and then we'll do the same thing with our blue line, right? So like I would have to draw that. Back in, and then I would find the slope there. Okay, so that's how you make your graph. And then remember, if we're saying mass over volume is our density, right? Well, think about how we're calculating our slope. We're calculating our slope. I'll just write it up here. Is rise over run. Well, my rise, right? You're really determining the mass over the run is the volume. And then what did we say mass over volume is? Mass over volume is density. So essentially your slope is going to equal your density. The reason we plot several dots on a graph, draw a line of it, best fit, and then take the slope instead of just taking one data point and, you know, measuring the mass and the volume and dividing and going with the density is think about, you know, we're using extremely small numbers here. And so our chance of being accurate is very small. So if we can look at a larger data set, you know, plot some points, draw kind of an average line or take the average, you know, of our data set, it's going to give us a much more reliable answer. So that's essentially what you're doing in this graphing section is finding the slope because our slope equals our density, and then you can find the density of the at 3 different samples, okay? And then whatever our blue line, you know, the slope is going to equal density as well, okay? So hopefully that helps. Let me know if you have any other questions.